Hi guys, I'm back. This is a 1970 JMP 50 watt. It belongs to a guy who lives over in Perth, which is on the other side of Australia from where I am here in Melbourne. This guy, Sean, actually has bought one of my Alta 100s, right? One of the first 5 runs. So he's a good guy. This amp has been sitting here waiting for me to look at, and I've been out of action for about a month, right? I went and had some surgery on my knee. Some of you guys might be aware of that. And I'm on the road to recovery, and I've been dying to get back into this and have a look at this thing, right? I haven't opened it up. It's in beautiful condition, isn't it? Look at it. You know, I want to show you the back. So if we turn this thing around, I've had a lot of old Marshalls in here, and I don't think I've had one in that looked that clean. Power connector's obviously been changed, right? So someone's put a modern IEC connector in here. It's still got its original mains and impedance selectors. The original badging on the back here, right? Jim Marshall products. And what's really interesting here, and we'll see when we open this thing up and have a look, right? This has got a badge up here. It says stock number 1986, right? So if you know your Marshalls, you'll know 1987 model number is the 50 watt lead spec. 1986 is a 50 watt base spec amp. Right? The difference between the 87 and the 86 is in the 86 base amp, you'll have a shared cathode for V1A and V1B, and some different values in the tone stack. The kind of notable differences. We're not sure. Sean's not sure. He did send me a clip. This was actually bought from a retail store in Perth called the Rock Inn, and those guys posted a video of this amp. Let's have a listen to it now. All right, let's have a look at this JMP 50. Pretty good condition. There's some obvious things, right? But first of all, that label is one of the best preserved I have seen, and you can see the date on it, 1st of December 1970. Right. UK date format. That'll be the 1st of December 1970. Original choke, original output transformer, thankfully. Clearly not original. So this PT, I'm not sure of it. There's no markings on it, so I don't actually know what it is. If anyone can recognize that and let me know in the comments, that would be really good. Looks a bit, I wouldn't say undersized. It's probably unfair. Maybe I'm just used to working with 100 watters lately. Let's have a look. What do we got here? Ooh, English. Right, that's an English made tube. You can see it. So whoever owned this was pretty serious about trying to keep the old stuff there. This is the same. That's exactly the same. And that one is exactly the same again. All right, so that's a set. These are obviously not original. Just good old JJ EL34. They look okay. All right, obviously, right, missing mains cap. So this is intriguing. You obviously can't operate an amp without that. This is the screens and phase inverter. So RS cap, right? So would have been replaced. This one here looks original. Right, so interestingly, if you look at these, this one's a 32 plus 32, right, which is not the original spec, right? These 1986 50 watts were 50 microfarad all around. That's the original one, and it's 50 plus 50. Right. Let's flick it over and see what awaits us. Wow, do you look at this, right? It's pretty clean, guys. Look, I'm going to start with the pots here. These all look completely original, right? And obviously original mustard presence cap on here. This wiring, the wire looks original. Right. These jacks here all look original. Over to the tube sockets, these riveted, right? All riveted in, all original. These will be original as well. You can see, as I noticed from the outside, right, fuse holders, impedance, main selector, speaker jacks even. It's pretty clean, right? There's some gold in here. Look at the main board, main circuit board. Wow, okay, first thing I've noticed, it's missing a few nuts, right? These standoffs, you see that? Right, here, and here. All right, not fantastic. There'll be a bit of, solid in there, but, going to work on the amp, guys. Save all the nuts, put them in a little plastic container. Just look through the board here. Right, original mustard coupling caps. All these resistors look completely original. Right. The old dog bone caps here. So this is original. Now, as we noticed on the outside, had a 1986 stock number on it. It is a 1986. This is definitely a base 50 watt. Look at this yellow wire here. Right, this yellow wire comes up here. This is our cathode resistor. It's an 820 ohm resistor, and that'll be a 330 microfarad bypass cap. And it comes across here, and it jumps across to the other side. This is a shared cathode, right? A lead spec amp will have a split cathode, and you'll have another yellow wire here with a separate, normally a 2K7 and a 0.68 microfarad bypass, right? To give you the kind of the high triple channel and the normal channel. This is good old shared cathode base spec amp. Pretty interesting. So it's completely original. Often you'll see these and they've been, modded to a lead spec amp. So, pretty cool, I guess, to see this original. Look at the tone stack. All right. Again, in a lead spec tone stack, you'd have, 470 or 500 picofarad cap here. It's a 250. All right. And you'd have a 33K slope resistor. All right. Not here. This is a 56K. Right. 22 nanofarad. That's the same for lead or base spec. Let's have a look what else is going on here, right? 0.1 microfarad couplers on the phase inverter. That would actually be in a lead spec amp. You could have those. I've actually got a video comparing in my 1969 50 watt JMP the sound difference between 0.022 and 0.1 mustard caps in here. 47K negative feedback resistor, which is coming off the speaker jack. All right, okay. Don't know if, Marshall would have wired them onto the impedance selectors, I would have thought. Now you can see some stuff going on here that's not original because the power transformer's been replaced, and I can see these the green twisted wire here. This is the heater line, and someone is on the tube socket here put a couple of resistors to ground. This is creating a faux center tap. Okay, I might measure those resistors. It's hard to see what they are. Normally you do this with 100 ohms. So this PT clearly didn't have a center tap on the heater. Some of them don't, but that's what you do. You just set up a faux center tap like that so you can ground. The heaters need a ground reference. Now, so this is all looking beautiful and pristine and original here. This is where stuff gets a bit crazy. This is a high voltage secondary from this power transformer, and we've got another red wire here which is tapping off one of them for the bias supply. So this is a stock circuit, well, you know, original wiring, but this is not original. What am I saying here? They're following the original schematic, but it's not original wiring. 2 rectifier diodes set up in a 2-phase rectifier arrangement going to this little tag strip here. And we are coming off that with this red wire here, which goes to the blue wire to the standby switch. All right, so the standby, which is not original. This power switch is original. This is not. The standby has been inserted after the rectifier, but before the mains filter cap. And this is it here, right? So I said this thing had the mains filter cap was gone. Well, it's been replaced by this axial here, which I'm struggling to get to see the markings on it, but I will measure that. This cap here is a 0.47 microfarad, and it's running from the standby switch to ground. This is to help. I noticed my 69 Marshall had this put in it as well to help stop loud pops coming through your speaker cabinet when you're flicking the standby switch, right? So that cap's just kind of off the standby switch to ground, trying to eliminate those pops. So this is all a bit of a mess, really. I mean, this is kind of okay, I guess, but it's not awesome. Don't like that. I'd like to put a can, let's put an original can cap back in here. The other thing I've noticed, which I don't like, is that the ground for the IEC is a shared ground with this white guy here, which will be the center tap for these secondaries here. All right, so in a 2-phase rectifier setup, your high voltage secondaries will have a grounded center. Your ground for your IEC connector, your main earth, should always be separate. All right, run to its own ground lug, away where it's not shared with anything else. Just common practice safety. All right, that's not good. And I can see there's kind of like a hole there where there should have been, where you'd expect to see that ground lug. I have no idea what this little clip thing here is for. God knows what was there before. So yeah, bit of cleanup to do in the mains filtering here. This looks awesome in terms of its originality. I've had a quick chat to Sean about this because I've had a look at this for 30 seconds and went, yeah, it's base spec. What we're going to do is we're going to recap this. Right? We're going to change out all of the filter caps. We will put new bias caps in as well, because these look completely original. So if you're going to change the filter caps, do the bias caps at the same time. I'll check everything else over as well, and we'll see how it sounds, right? So once the service work is done, I'll take some clips for him, see how it sounds as a base spec 50 watter. I mean, he's a guitar player, right? Not a bass player. He might prefer to keep it stock as a 1986 spec amp. Right, so before we fire this up and check some voltages and so on, and give it our own little sound test, I'm going to check these can caps, right? So I've already kind of said from an age perspective, they look like they should be replaced, and we want to kind of get rid of this, right, and go back to a traditional main setup here. I'm just going to use my little handheld LCR meter here, which I've picked up recently, and this is pretty cool, right? So what this allows us to do is to measure far more accurately capacitance and inductance and reactance. In fact, with a normal digital multimeter, they will measure capacitance reasonably well, but you certainly cannot measure inductance or reactance with it, right? So the cool thing about these LCR meters, if you're not aware, is that they measure capacitance, reactance, or inductance via a frequency. All right, so I've dialed in 100 hertz here because 100 hertz is exactly what this mains filter cap would be dealing with. It's bridge rectified mains, right? 50 hertz here in Australia, so 100. So I want to test it, you know, its properties at 100 hertz. If I was in the US, then I'd set this to 120. And you'll actually find, if you toggle through the frequency selections here, it goes all the way up to, you know, 20K or whatever. The capacitance of that component will vary, right? It's not linear. So here's our mains filter cap. It's showing 82, you know, so that's kind of, it's okay. 20% under. We want 100 here, so it's not the end of the world. Let me go to the screen. This is the screen cap here. So on this component, it actually says 32 plus 32. So this is showing 81, which is kind of way out of range. And let's look at this as a phase inverter filter. Right, 38, so closer to the 32. So this one's drifted, right? Let's move and have a look at, I'm just going to kind of come over here and see what we can measure with respect to the preamp. Okay, so this will be one side of the can cap that's under the board here. Now this is a 50 plus 50, so that's 46, that's pretty good. The other side, 38, right, it's quite low. So this is just telling me that, you know, replacing these is probably a good idea, right? They're probably due, certainly old enough to be. I've got my bias probes, 2 of them, right? Already plugged in, ready to go here. So let me bring the voltage up. I'm dialed in at 240 on my variac here, so we're at normal mains voltage. And let's put the good old fluke meter right there. And what I might actually measure to begin with, given that this is a new, I've got a replacement power transformer in here. Let's see if we can get a reading off the heaters. 6.3, it's pretty good. Can't complain with that. All right, let's go to DC, bring the amp out of standby, get my ground reference there, and let's go, let's go straight to pin 3 on the power tubes, right, the plate, 455. Okay, you can see it. My bias probe here is showing the same voltage as is this one. Okay, we'll get to the bias current in a second. I can see that it looks like it's biased coldly. So this is actually the B plus, right? This is the filtered rectified voltage from the high voltage secondaries, okay, it passes across to the HT fuse, and from here it's going to go off to the primaries of the output transformer and also the choke. When it comes back through the other side of the choke, it then sets up our screen supply, right? And our screen supply is this side here, which goes to pin 4 on these power tubes, right? The yellow wire. It'll always be a couple of volts, 1 or 2 volts. So let's call that 453. It's a bit unusual. Well, we'll continue on. So here's our screen supply node. We've got 2 droppers here, right? Look like 8.2K and 8.2K. This is the phase inverter supply, which in a Plexi 330 is pretty much the magic number. So that looks very good. All right, just from a voltage. Here's the other side of that, 228. All right, so this is the supply node for V2, and then finally the supply node for V1 at 270. Let's have a look at what's going on here. All right, so at this kind of plate voltage, if you're biasing up at 65% plate dissipation or whatever, you'd want to be reading 32 around, something like that, right? 18 and 23, that's very coldly biased. One of the things that raised my suspicion about the power supply section in this amp was that there was no voltage drop between the supply, the B plus supply for the plate, right, and the supply node for the screens. There was no voltage drop whatsoever. In fact, my meter was kind of reading the screens almost slightly higher, which was maybe just a bit erroneous, but you always expect a voltage drop there of some description, right? A couple of volts, maybe 5, in an amp that's biased, warmly, but at least a couple of volts. And there wasn't, and it aroused my suspicion instantly. One of the things I did off camera, I didn't record it, was I actually checked the AC voltage. And it's a previous JMP video I did where there was a faulty choke. I actually found the fault by checking the AC, or the amount of ripple on the power supply lines, right? So I checked it on the B plus, and I checked it on the screen node. And on the B plus, it's normal to get a couple of volts AC of ripple, right? Common mode cancellation in a push-pull amp, it actually cancels each other out, so you don't get any actually hum. But if you've got that ripple on the screens, you will get hum in the amp. And I measured the AC at the screen supply node here, and it was the same as the AC as measured on the plates, right, here or here or here. It was about 1.5 volts AC ripple, and it was the same on the screen. So I was like, hang on, that should not happen, right? It should not happen. And what I was suspicious of then was that this choke is probably short-circuited. So over time, a choke is an inductor. It's a wire around core. And over time, sometimes, the PVC on the wire, or the coating on the wire will break down, and or whatever, and you'll actually end up with a short, and so the inductor just is like a piece of wire. It's no longer a filter choke. So I'm using my good old LCR meter here, and I've just disconnected. That's the center tap for the primary of the output transformer, and it was connected to the side of the HT fuse, as is one end of the choke that's there as well. So I've just taken these off, right, cleaned up that fuse there. That's one side of the choke. The other side of the choke is this black wire here, which connects back in onto the screen supply node, right? So that's how the screen supply node gets its power. And if I measure this, so I'm going to go from here to here. And I remove this out of the circuit because I just wanted to be doubly sure. Because when I measured it when it was in circuit, I got a reading like this. Right, 50, 40, it's a millihenries. Right, you might as well have nothing. Demonstrate what you should get. This is a Haber plexi choke. Right, so if I measure this by way of comparison, you see the meter doesn't lie. 3.8 henries, right? Not millihenries, henries. Right, so this old 50 watt 1970 JMP, unfortunately, it's going to need a new choke. So I'm going to pass that bad news on to the owner. I've already spoken with Sean. We are going to replace all the filter caps, right? He's cool with that. We'll replace the bias caps. He's cool with that as well. I haven't spoken to him about screens. About the filter choke. I'll do that now. I suspect, therefore, that when I turn this amp on, we're going to have a level of 100 hertz hum in it, right? Because if the choke's not doing its job, we're going to get some hum in the amp. So I'll just reconnect this in the meantime, right? We can get on with the rest of the job. I will power this up in its current state. Let's at least bias it correctly, and we'll have a listen to what the thing sounds like at the moment. All right, I'm just powering the amp up now, and we're going to do the bias because I've got no intention to change these power tubes. I will comment, right, one of the other things I'm going to need to do here. This amp's got no screen resistors. I'm sure someone's already spotted it in the video so far. I'm not sure it ever had them. I'm going to check this against the 1986 schematic, right? We'll do that. Definitely do that. But that normally you'd see your screen resistors, of course, the 5 watt, right? Normally 1K. You'll see them, sit across pin 4 and pin 6. Pin 4 is not used in the EL34s. It's just there as an anchor point, basically. There's no evidence of there being solder on those pins. Both of them look clean. So this could well be like that from the factory. It's pretty interesting. Given that there's been some prior work on this, I'm surprised that someone hasn't added them. Anyway, actually, while we're here, right, I'm going to demonstrate what I was talking about with respect to the AC ripple on the power supply. All right, so I'm bringing the amp out of standby, and all right, here's our B+. Okay, happy with that. Pin 3 plate. Now, if I move this to AC, you see, right, 1.3 volts. That's normal. That's cool. It's fine. Right. However, if you measure this at the screen supply node, it should be 0.1. See, it's the same. All right. It tells you straight away that the choke is doing nothing, absolutely nothing. If I move it to here, which is where the phase inverter supply is, and remember the phase inverter supply has its own filter cap, by the time you get to here, it's coming down right and getting sorted. But, you know, there you go. Barely a ripple there, right? 10, 13, 15 millivolts, hardly anything. But here, you know, it's the same, right, as the B+, which is a no-no. You see if we do something about this bias. You can see these guys are 5 milliamps apart, which, you know, not the best match set you'll ever see, but close enough. 5 milliamps is really the rule of thumb, right, in terms of being a match set. All right, so let's see if we can bring this up. Good news is there is some adjustment in this bias pot. I'm kind of going to get it 32, kind of halfway, right? So one will be running a little bit above, one a little bit below. It's probably about there. Yeah, it's probably okay. All right, let's put this on the scope, see what's cooking. All right, so I've got the scope on, and I'm going to run my test signal into the front, and I'm going to connect the probe of the oscilloscope to the speaker. I've got it running into a 16 ohm resistive load. Okay, and my scope has a signal generator built into it, so we're setting this to, I do 150 millivolts, which is about the same amplitude as guitar being plugged into the front end. Turn the generator on, go back to this, right, and I'll put it on measuring here so we can see. Let's power the amp up. And what I'm looking for here is just kind of whether, you know, this thing is putting out a relatively clean signal, you know, when it breaks up and so on. So out of standby now, and let's bring it up. Okay, so it's pretty healthy. Now what's pretty interesting, right, is that this amp, if you have a look at this, right, see what's going on here. It's pretty loud at this point, right? You can see, I'm going to just bring this back down to 20 volts per division. I'm cranking this volume now, right? That's right up. So we're pushing into power amp distortion now, right? You can see this kind of crossover distortion start to come here. But what it's showing me is that at, you know, lower levels of volume here, you know, what's the volume here? It's on about 4. About halfway, about 5, it breaks into squaring off, right, and clipping in the power amp. But up until then, in the preamp, it's clean, right? This is a base spec amp in a Plexi 50 watt lead spec with a bright cap on here. We'd be getting some clipping on this before we reach that point. Pretty interesting. You can also see, bring these up, you can see the voltage sag under load, right? So if I bring this up, see how the voltage drops. right? So, you know, okay, good. I think it would be better with a choke. that would work. But what's probably interesting for me is how clean the preamp is. I guess not surprising, right? Shared cathode, no bright cap, you know, base spec, right? Nowhere near aggressive, nowhere near as aggressive as a lead spec amp. Okay, so let's have a look at the schematics for 1986, right? The base 50 watt JMP and the 1987 lead spec, right? So very handy that I've got, or Marshall put out, July 1970, right? So this is a December 1970 amp. So this is like bang on, period correct schematic. And let's just kind of use this to call out the differences between the two. Now I've already kind of mentioned those as I've went through obviously the amp itself, but let's just compare this back to the schematic. Right, the first thing I talked about was common cathode. This is this arrangement here, right? So this is V1. Right? If you're not familiar with understanding schematics, then maybe what I go through here you might find in some way useful. This is where your guitar is plugged in, right? These are the 4 inputs here. And you can see that these two, high and low, come into this side of V1. And these two here come in to the other side. This is called the grid, right? These are your anodes or plate. And down here is your cathodes, right? And these are tied together through a single resistor and a single bypass cap, the 820 ohm resistor and it's a 320 microfarad. Now we talked about that when we looked actually at the board, right? But you can see it here represented in the schematic. All right, so let's flick across to the lead spec amp and you can see the arrangement here is the same in terms of the inputs, but the cathodes are not tied together. Each side of V1, so each one of these is a triode, one triode here, one triode here. So we've got the 820 and the 320 here, but completely separate to that is the 2.7K and 0.68 microfarad. This is kind of the high treble channel and this is the normal channel. Let's move back to the bass amp and here are our 2 volumes. All right, volumes for each channel, and you can see, well you can't see I should say, there's no bright cap on either of these channels. And if we look at the lead spec amp, you'll see here 0.005, that's a 5,000 picofarad bright cap, which you'll see on the high treble channel. Okay, so no bright cap in the bass amp, which we saw. Let's look at the tone stack. Here we go here, right? This is the treble, that's the bass pot, and this is the mid pot here. And here's our treble cap, 250 picofarad and a 56K slope resistor. Okay, as we saw in this JMP 50 that we're looking at. And you can see here in the lead spec amp, it's a 500 picofarad and a 33K. All right, so far we've seen the differences here. Now, the other thing that was really kind of noticeable in the bass amp was these couplers for the phase inverter, so 0.1 microfarad, right? So you do get those in the lead spec amp sometimes as well, but you can see in this schematic they are 0.022 microfarad, right? There are some other kind of differences here, like you can see the presence cap here is a 0.68 microfarad on this schematic here, and it's a 0.1. But, it's very common to see lead spec amps with 0.1 as well, right? So these kind of, small differences here, but they're not the main differences that you would see. Now, the other observation that I made when we went through the amp was that there were no screen resistors on this bass amp, right? And we can see them well, we can see that they're not here. If we go to the lead spec amp, here they are here, right? 1K, 5 watt. And it's coming off the screen supply node. So this schematic's not quite as clear as the other one, but you can see here, this is our rectifier here, the 2 diodes from the high voltage secondary. We have 250 microfarad cap, that's the first CAN cap in parallel, right? So 100 microfarads of filter. That goes off to the center tap on the primary side of the output transformer. Then it goes through the choke, right? This is our B+ line. And here's the screen supply node, right? So 1K off to the screen control grid and a 1K off to the screen control grid. Now, if we compare that to the base amp, you can see this one's a little bit clearer. Same rectifier setup, the same 100 microfarad mains filter cap. This is the HT fuse. Here we come off center tap to the primary, right? So the center tap to the primary side of the output transformer, and you can see each side of the primary connects actually to the power tubes. This is connecting to the plate, right? This is pin 3 on your power tubes. It's how your power tubes actually get their B+ supply. In case you didn't know, it's actually via the primary side of the output transformer. Here's our choke, and here's our screen supply node, and you can see, as per our amp, right, it's factory. No screen resistors here at all. I'll discuss this with Sean. I think it's a very good idea to put these in. Alright guys, let's give this 50 watt JMP 1986 base spec amp a bit of a tone test, right, before I get in and actually, start to put some work into this thing. So this is as we received it. See, I've got the volume here. About probably up about 3, give or take, right? And I'm in the kind of a high treble channel. Play my bridge pickup. A bit of breakup there, of course, right? It's a bit sounds like a shared cathode to me, right? It's not the lead spec amp that I'm used to hearing and used to playing to. This would be a good pedal platform, I guess, to use that term, or someone who wants big clean amp with a big bottom end in it. You could certainly use this amp for that. Bring the volume up a bit. Yeah, see, that's getting really undefined for me in the bottom end, right? Like a lead spec plexi will still, it'll loosen up a bit, right? But you've got that upper mid-range bite that's kind of keeping the whole thing together. That's starting to get very woolly for me. Yeah.
It's got a vibe about it, right? It's not terrible. Stick around for part 2, right? Part 1 video is just kind of checking out the stock amp, going through all the measurements that we've put together here. Part 2, we will do the kind of the restoration of the filter caps. Obviously need a new choke in this amp as well, and I'll be chatting to the owner of this amp, Sean, about whether we're going to keep the base spec in place or move this thing to a lead spec 50 watt. Hope you enjoyed the video, guys. If you haven't subscribed to my channel, then please do. I'd really appreciate it, right? Like, subscribe, all that good stuff. And I'll see you next time.